Data cleansing is at the heart of data quality. It is the process of validating entered data and converting it into its best form. Data Quality Center is built for data cleansing. It has many algorithms designed for both specific and generic types of data cleansing. Let's take a look at one of the included examples. This plan file is used to cleanse Canadian social insurance numbers. It uses the step called SIN validator, which is designed for exactly this purpose. Here's our column of input SIN records. Notice that there are several different formats. We want to get rid of the unnecessary information and leave only what is useful. Our plan file consists of two primary steps. First, we will prepare the data for validation, and then we will validate it using the SIN validator step. Let's take a look at the column assigner step first. We can see that there are 3 assignments and that all of them write to the same column. This is so that we can handle the various scenarios that we expect to encounter. In the first assignment, we simply copy the data from our input column to a new column called PUR_SIN. The prefix PUR stands for purified, and it is a convention that indicates the data has been parsed and possibly cleansed in some way. We don't want to overwrite our input data, so we always create new columns whenever we will be modifying original data. Next, we want to correct any of the copied source values that have non-digits in them, such as dashes and text. This way, our SIN data will contain only numbers. Finally, we create a complex expression that is used for cases where the social insurance number is less than 9 digits. This may occur for invalid entries, but older social insurance numbers may be less than 9 digits long and still valid. This expression adds leading zeros to numbers that are less than 9 digits long. We can use the debug functionality to test the expression by entering values in the value column. Notice that typing any number with less than 9 digits generates a 9-digit number with leading zeros, whereas non-numbers and longer numbers are left as they are. Notice that each assignment node has another set of properties called scoring. Scoring is a way to track the number and severity of changes that are made to data. Let's look at the score node for the second assignment. If an SIN was entered with non-digit characters in it, it still may be a valid SIN number. For example, dashes can be used to separate groups of digits. However, it could also be the result of an invalid entry, such as an address in the SIN field. Therefore, if an SIN value has non-digits in it, we would like to note this somehow. We do this by adding cumulative score values for each non-standard format encountered. At the end of our processing, those entries with higher scores are more likely to be, though not necessarily, incorrect entries. We can assign different score weights for different scenarios. In this step, we assign a score of 10 if the second or third assignment is performed. Notice that we can also provide an explanation for each score, so that we can learn how the scores were calculated later on. Now let's move on to the next step. This step is specific to Canadian social insurance numbers and knows the format rules for such numbers, such as length and check digit calculation, so it is very simple to configure. It mainly consists of specifying an input column and output column. Notice that we use the STD prefix for such values. This means standardized and indicates the entries have been validated by some formal algorithm and represent our final cleansed values. In the score node, we assign much higher scores to entries that don't pass the validation, since this test is more sophisticated. If it does not pass this validation test, then it is quite likely to be invalid. So now let's run the plan to generate the output file. We see 4 new columns that have been added. The PUR_SIN column has the extra character stripped out and an extra 0 added in one case. The STD_SIN column is the same, except that one entry was removed due to not passing the check digit test. Finally, we see the score and explanation columns that have recorded the changes made to each entry. If an entry is scored multiple times, the scores are added together. We see the last row was scored twice and has a cumulative score of 1010. Viewing the results of tens of thousands of records or more can be overwhelming, so DQC offers a method to customize how data is shown. For example, we can quickly resize the columns by right-clicking on any row header and selecting Auto Fit All Columns. And if we want to highlight all rows that have a score greater than 1000, we can use the Data Viewer Settings dialog to specify a coloring rule. Several other settings are also available, such as filtering and hiding columns, and are described in the documentation. This is an overview of cleansing in DQC. Please refer to the other plant files in the Tutorials folder for more examples.